Hello, this is Miss Brubeck. I'm going to be doing notes on how to find the greatest common factor. So today, students will be able to find prime factorizations of integers and the greatest common factor of integers. So first, I'm going to go over some definitions for you. And the first is prime number. A prime number is a number who has factors. The factors are 1 in itself. So numbers like 3, 5, 7, 11, 13, 15 is actually not a prime number. 7 and 19, those are all prime, and I'll show you why. If we have the number 5 and we break it down, the only numbers that multiply to get us 5 are 5 and 1. No other number multiplies to get us 5. The same thing is true about the number 11. The only numbers that multiply to get us 11 are 1 and 11. If that is the case, that is called a prime number. The word factor that's numbers that when you multiply them, it equals something else. So like 1 and 11 are going to be factors of 11. Then we have composite numbers. Composite numbers have 2 factors. So like 2, 6, 8, and 10 are all composite numbers. So like if I have 6, I can break that down to 1 and 6, but then I can break the 6 down into 2 more prime numbers of 3 and 2. So it breaks down to 1, 3, and 2. Finally, we have prime factorization. That is when a whole number is expressed as the product means multiplication, product of factors that are all prime numbers. So let me give you an example. Let's use the number 30. If we break down the number 30, that can be multiplied to 3 and 10. You could also do 5 and 6. And then 10 breaks down to 5 and 2. And so our factors are 3, 5, and 2. So the way you write the prime factorization is you say 2 times 3 times 5. And that's how you write the prime factorization. And we'll talk more about that in today's notes. So I'm going to go ahead and move on to slide 2. Nothing you have to write down there. On your Jamboard, problem number 1 is already done for you. The 90 is done for you, but I'm going to go ahead and do it for us here. So the way we break this down is we want to find the prime factorization by making a factor tree. So we can break down 90 by its factors, numbers that multiply to get us 90. I'm going to use 10 and 9, and then you want to break down 10. So 10 breaks down to 5 and 2, and 9 breaks down to 3 times 3. So now we have all prime numbers. 5, 2, 3, and 3 are all prime numbers. I'm going to circle the ends of my factor tree. And so the prime factorization of 90 is going to be 5 times 2 times 3 times 3. And that is the prime factorization of 90. I'm going to do the same thing for 12. I'm going to think what numbers multiply to get us 12. I'm going to use 3 and 4. You can also use 6 and 2. 3 is prime, but I can break down the 4 to 2 times 2. So then you want to circle the bottom, the ends of your factor tree. 3, 2, and 2 are my prime numbers. So prime factorization of 12 is going to be 3 times 2 times 2. And that's how you find the prime factorization of a positive number. I'm going to go ahead and move on to the next slide. Now we have a negative number. So for a negative number, what you want to do is you want to pull out the negative 1. So what that is going to look like is I'm going to pull out a negative 1, and I can say that negative 1 times a positive 140 equals 140. So you pull out a negative 1, and then you can break down the 140. So that 140, that 14 times 10 equals 140. Then we can break down the 14 to 7 times 2. We can break down the 10 to 5 times 2. that's a 5. And then you just circle the ends of your factor tree. So -1, 7, 2, 5, and 2. So the prime factorization is going to be -1 times 7 times 2 times 5 times 2. For the next one, -20, we need to factor out a -1. So we're going to take out a -1. So -1 times 20, a negative times a positive equals a negative. If we break down the 20, I'm going to break it down to 10 and 2. And then I can break down the 10 into a 5 and a 2. So again, you want to then circle all of the prime numbers at the end of your factor tree. -1, 5, 2, and 2. And so prime factorization of 20 is going to be -1 times 5 times 2 times 2. It doesn't matter the order you write the numbers in, you just got to make sure you get all of the factors written down. Next, we are going to do the prime factorization of a monomial. So the next two examples we're going to do have variables in them. So for this one, let's see here. Let me get this erased. And I can't seem to get it erased. I'll just do it like this. We want to break down the 12 first. So the 12 breaks down, we can break it down a couple different ways, 3 and 4 or 6 and 2. I'm going to use 6 and 2. So 6 times 2. Then we can break down the 6 to be a 3 times 2. So our prime factorization is going to include a 2, a 2, and a 3. But then we also have to include our variables. So we have a squared, or a to the second power. That means we have two a's. A squared, or a to the second power, means we have two a's. So a times a. And then we have b to the third power. That means we have three b's. I'm drawing little multiplication signs in between. Three b's. So when we draw the prime factorization, we write out the prime factorization, not only do we need to write out 3 times 2 times 2, we also need to include the a's and the b's. So our answer is going to include 2 a's and 3 b's. And that is the prime factorization for 12, a squared b to the third. For the next one, we have a negative number. We have a -66. So I'm going to take out a -1, and then I'm going to have 66. And I'm going to break down 66 by doing 11 times 6. Now 11 is a prime number. The only numbers that multiply to get us 11 are 1 and 11. So we can stop there with 11. But 6 multiplies to get us 3 and 2. So the numbers for our prime factorization are going to be -1, 11, 3, and 2. But then we also need to break down the p's and the q's. So the first p is just 1 p. So we'll have 1 p right here. And then q is squared. So we'll have 2 q's. So when we're writing down the prime factorization, we will include the -1, the 11, the 3, and the 2, but then we'll also include 1 p and 2 q's. And that is how you do that prime factorization. I'm going to move on to the next slide. So this next one, they already did the prime factorization for you. They're showing you the prime factorization of 48 and 60. So if you were to work out a factor tree for 48, you would get 2 times 2 times 2 times 2 times 3. And if you were to work out a factor tree for 60, you would get 2 times 2 times 3 times 5. Before, we've been finding the prime factorization. Now we want to find the greatest common factor. And so we want to figure out what numbers do they both share? What factors do 48 and 60 share? Well, 48 shares a 2. and 48 and 60 share another 2, and then they share a 3. Now they don't share a 5 because even though 60 has a 5, 48 does not. And then the other 2's in the 48, we can't include those. So we'll include our 2. We have 2 2's and a 3. And if we multiply those out, 2 times 2 is 4, and then 4 times 3 is 12. So our greatest common factor is going to be 12. Moving on to the next slide. The next slide, we want to find the GCF of 16 and 24. Okay, so we want to break those down. I'm going to erase what I have here. And think what numbers multiply to get us 16 and what numbers multiply to get us 24. So off the top of my head, for 16, I'm going to use 8 and 2. I'm going to use 8 and 2 for 16. 2 cannot be broken down anymore, but 8 can be. We'll break that down to a 2 and a 4. And then the 4 can be broken down more as well. 2 and 2. So the prime factorization for 16 is going to be 2 times 2 times 2 times 2. And then for 24, I'm going to use 12 and 2. There's different options you could use. I'm going to use 12 and 2. And then 12 can be broken down. I'm going to break it down to 6 and 2. And then 6 can be broken down to 2 and 3. And so the prime factorization of 24 is going to be 2 times 2 times 3 times 2. So 2 times 2 times 3 times 2. And then we want to figure out what numbers do they share. So they share a 2. They share another 2. And it looks like they share one more 2. And so we can, yeah, that's correct. They share this too. So they share 3 2's. So 2 times 2 times 2 is 8. So our greatest common factor is going to be 8. And then you want to do the same thing for the one down here. So 36, I'm going to break 36 down to 6 times 6. So 6 times 6, and then I can break down the 6 down to 3 times 2 and 3 times 2. But then pay close attention to the x's and the y's. So then we're going to have 2 x's, and we're going to have a y. So our prime factorization is going to be 3 times 2 times 3 times 2 times x times x times y. So I'm just going to write 54 here, and I'll put the prime factorization is 3 times 2 times 3 times 2 times, I'll make a big X to show the X, times X times Y. And then for 54, I'm going to break 54, I'm going to do it over here like this. I'm going to break 54 down to 9 and 6. So 9 times 6. And then 3 breaks down, 9 breaks down to 3 times 3. 6 breaks down to 3 times 2. And then we've got an X. We've got 2 Y's. And we have a Z. So our factors are going to be, 3 times 3 times 3 times 2 times x times y times z. So that is our breakdown for 54. Oh, sorry, I wrote a 54 here, and I should have put a 36. And then our breakdown for 54 is going to be 3 times 3 times 3 times 2 times x times y times z. And our GCF, you just want to look at the numbers that they share, and that'll be your GCF. Looks like I'm running out of time on my video, but you just want to look at the numbers that they share, and that will